Okay, our first one says be able to identify statements in logic. What we were studying there is that commands are not statements. Okay, so do your homework is not a statement as far as logic is concerned, and questions are not statements. That one won't be tested specifically.
Where is this?
This is front page of our
So when we talked about that in the lesson, we were just determining what exactly does statement mean in terms of logic. It's not a command, it's not a question, but I'm not going to test you specifically on that objective. Being able to represent statements symbolically. These are the kind of problems where I told you, let's say P is, it is sunny, and Q is, I go to the beach, and then we would take stuff like, if it is sunny, then I will go to the beach, and we turn that into symbols, P, arrow, Q. Okay, it is sunny, and I will go to the beach, P, upward mountain, Q, right? So know your logic symbols, okay? Know the symbol if then, know the symbol or, and.
What is the like arrow like both ways?
Arrow both ways is if and only if. That's our biconditional statement that works in both directions. It says if and only if. That goes both ways. If it's just if then, it's the one directional arrow. And know our negation symbol. So if we're saying not, then we do that symbol. So being able to take words and turn them into these symbols. And vice versa. Being able to take symbols and then turn them back into their words. Okay, so that's the being able to represent statements symbolically that will be tested. Computing truth tables. Okay, so there will be some truth tables on here. So being able to compute a truth table. Remember the setup, there are only going to be 2-letter truth tables on the test. I'm not going to do 3-letter truth tables. So our setup is true, true, false, false, true, false, true, false. If you don't remember that, just ask during the test and I'll give you like that first part so that we're all consistent in that, and then from there be able to create them. If you remember that, that's great, but you know, that's not a big deal to me. If you need to ask me, I will tell you that's how we start it. And then you can.
You get in there and you just forget and you can't.
So
Sad.
so that's how they start, and then we fill in all of our logic. Some things to be careful of. The question then, okay? Remember that then, if we have a true, false, what is that?
False.
False, okay? What about if I have a true, true?
True.
What about if I have a false, true?
True.
Still true. And a false, false?
True.
Still true. In a one-directional arrow, the only way we end up with a false is if we start with a true premise and end with a false conclusion, or true antecedent and end with a false conclusion. That means somebody was telling a lie. Otherwise, it either is definitely true or it's ambiguous and we call it true. Okay. Any questions about anything else for truth tables? I think that's usually the trickiest one.
Or it just has to have one true no matter the order.
Yep, or has to be at least one of them is true. So it could be one, it could be the other, it could be both. And that's still okay. So the only way an or is false is if both are false. And is both must be true. So for an and, it is only true if both are true, otherwise it's always going to be false.
The and is morally false. And there's one that's true and all false.
And is one that's true and all false. Yep, the only way and is true is if both parts are true.
If and only if is only like both.
If and only if, it would be like combining this but thinking about the arrow going both ways.
Will that be on the test or not?
It could be. So for if and only if, truth has to result in truth. So if it goes in the direction of PQ, truth has to result in truth. If it goes in the direction of QP, truth still has to result in truth. So is the first row of this true or false?
True.
True, because either way, true gives true. What about the second row? False, because the forward arrow, true results in false. That can't happen. Okay. What about the next one?
That would be true?
True.
Or is that just the one where there's just the one arrow?
If it was one arrow, it would be true.
It'd be false because one of the ways doesn't work.
Yep, it'd be false because the backwards direction here doesn't work. That Q is true, which results in a false P. So the backwards arrow runs into a problem. So that's false. What about the last one?
True.
That's true.
So basically, it's only if they're both the same.
Let's see. So this was lesson 1, this is lesson 2. Being able to determine logically equivalent statements, that was in lesson 2 as well. That's when you're going to make 2 individual truth tables and say that if they result in the exact same answer, then they are actually the same statement. Be reworded, but that they are logically equivalent statements. So if 2 truth tables end up being exactly the same, they are equivalent statements.
So that's where we like have the last part of the truth table is like underneath the symbol and you circle that part, right?
Mm-hmm.
Box in that part
And then the other
see
one.
if they're the same.
Mm-hmm.
It's the last 2 parts.
So the conclusions are
Yep. See if all the final conclusions are the same.
Wait, why is there 1, 2, 2 on the side?
That's what lesson they're in. So like if you wanted to go back and look at stuff in the lessons. Something else that we talked about when we talked about logically equivalent statements and truth tables was the word tautology. What does tautology mean?
Wait, we have to know what that means.
It's the opposite of self-contradictory.
It is the opposite of self-contradictory, so that's our other option. Okay, so what do those mean? How can I tell if a statement is a tautology or if it is self-contradictory?
Isn't tautology just always true or something?
Yep, a tautology will be a truth table that results in all truths,
And self-contradictory is just
results in all falses. Right, so that final answer column of our truth table for a tautology would be all truths. For self-contradictory would be all falses. So be able to recognize after making a truth table if it's a tautology or if it's self-contradictory. Okay.
Will you have a question, like, how will that be a question on that?
Here are some truth tables, or here are some statements. Create some truth tables. Are any of these like special statements?
Okay.
And then, yes, this one is a tautology because it's all true, or yes, this one is self-contradictory because it's all false. So make sure you know the words too, not just like that you would recognize them in a question, but you should actually know those words. Don't worry about spelling. If you spell tautology wrong, I'm not gonna pick on you for that.
Is there a way to like see if it's a tautology?
Only by making a truth table, and then in that truth table getting all truths. All right, being able to write a converse, inverse, and contrapositive. So that was in lesson 3. So what does a converse do? Converse flips them. Okay, so in symbols, if I say my statement is P then Q, a converse is Q then P. What does an inverse do?
Negates.
Keeps the order but negates them. Good word. And a contrapositive flips and negates. Okay, so be able to write converse, inverse, and contrapositive in words. So if I give you a statement that says something like, if I wake up early enough, then I'll go to Starbucks. Okay, be able to write a converse, inverse, and
So if I
contrapositive of that.
don't go to Starbucks, I won't wake up early.
That would be the contrapositive. Yep. We also talked about The words antecedent and consequent. When we were talking about our statements, the only one that I really want you to know, because we had some different forms that our statements can take, stuff like it is necessary for this or it is required for this. I'm most concerned about the fact that you understand what an if-then statement says. So the traditional if this, then this. The first part is the antecedent, and the last part is the consequent. Okay. So in the traditional if-then, know that the first part is called the antecedent and the last part is called the consequent.
So you won't have us like in the homework how it was, like label which one's which?
So yes, so be able to if I give you a statement, but I'm only going to test you on if-then. Okay, so it's one basic question, yes.
Wait, so
And
even if it's,
if-then, not the necessary ones, because those get really tricky for how you read that.
So
right, so
the
it's gonna count
antecedent will
sequence.
always come first then?
Antecedent will come first in an if-then statement.
Oh, yeah.
So,
But like, I remember some of them were like switched up, like,
right. Yeah, because they use words like necessary and
oh,
stuff like that when I get those on the test.
That's pretty necessary.
Then we talked about arguments, using truth tables to tell if an argument is valid. So that was in lesson 4. And remember the way that we use the truth table to tell for an argument is we use the truth table to create the premises and the conclusion. And then what we do is we look for anywhere that the premises are true that the conclusion ended up being false. Okay? That would create an invalid statement. Premises are true should mean true conclusion for a statement to be valid. So we did that in lesson 4. In lesson 4, we also had a chart that had common valid and invalid arguments. There were a lot of them, so I'm going to narrow that down for you. Make sure you know the 2 common invalid arguments. Okay. The 2 common invalid arguments are the fallacy of the converse and the fallacy of the inverse. So remembering what a converse and inverse are can help us out here. So in either one of those, we would have an if-then. What does a converse do? Flips it. So then our second premise would be the end, and it would conclude with the beginning, and that doesn't work, okay? Because that arrow only points in one direction. So P means Q, but Q doesn't necessarily mean P. So this is a fallacy. This is a fallacy of the converse, because it's switching their positions. This is
so we
converse.
need to identify both of those.
Could. At least one. Fallacy of the inverse starts with P to Q, and what does an inverse do? Negates. So I would negate and say not P should result in not Q, but that's not necessarily true. Okay? An inverse does not maintain a true statement.
So you want us to know all those fallacies?
These are the only 2 fallacies. The other ones were all valid statements, and they had weird names like modus tollens and stuff.
We don't need
Don't
them.
worry about those, worry about these 2. These are big deals, because this is what people do in arguments to you. Is they'll take an if-then statement and they'll turn it around backwards and place their argument on that. And that means everything they're saying after that is not valid, because they started out by doing something very wrong. You
Oh.
cannot take a converse.
So will the other ones be on the test as like a little help guide?
You won't need them. You don't need the valid arguments, you just need to know your invalids. And then, yesterday in lesson 5, learned to make those Euler diagrams, or Venn diagrams, where circles either totally overlap or somewhat overlap, and trying to place a conclusion into those. And then the last 2, we haven't directly talked about. a little bit here and there, but being able to think logically is something that is really just for us. So, like animals, they're not so logical. They live their life based off of instinct and necessity. So being able to think in a logical manner is something that is a gift to us because we are image bearers. And then understanding how logic can help us love our neighbor and then obey the mission mandate as well. So we've talked about logic and arguments. So it may not seem loving to argue with somebody, but helping them understand things better, misinterpreting scripture and being able to help them understand. Paul uses a whole lot of if-then statements and turns around and helping people understand that could be a way that we could fulfill loving our neighbor and our mission mandate is one way. There's lots of ways though that we can apply logic and reasoning to being able to hold better relationships with people and love them in that way. Questions?
Yeah, one question. This is the truth tables and determine if it's valid or invalid. Can you show us, like, say that real quick?
For an argument,
Yeah.
being able to determine if an argument is valid or invalid.
Yeah.
Okay, so when you create a truth table for an argument, you're going to have usually two premises. And so in your truth table, you will have each of those premises. The premises are like these parts, the part that come before the lines. And then you'll have your conclusion, okay? And what you're looking for in your truth table is any time that both the premises are true, that conclusion has to be true for it to be valid. So if you end up with premises working but conclusion not working, that's an invalid statement.
What if there were like three and two of them were true, one is false?
If there's any time that the premises are true and the conclusion is false, that doesn't work. Okay.